Hello, everyone. In this lesson, we will study the no-load characteristics and short-circuit characteristics of synchronous generators. When a synchronous generator operates stably under symmetrical load, maintaining constant speed, frequency, and power factor under these conditions, the generator's terminal voltage U, load current I, and excitation current IF are the three main operating parameters. They could all be measured during operation. They are interrelated. When one of these quantities is kept constant, the functional relationship between the other two quantities is called the operating characteristic. The operating characteristics of a synchronous generator include no-load characteristics, short-circuit characteristics, external characteristics, and regulation characteristics. This lesson will analyze and discuss no-load characteristics and short-circuit characteristics. 1. No-load characteristics. No-load characteristics refer to when the generator speed N is the rated speed, the stator winding terminals are open, and the stator current is zero. The relationship between no-load electromotive force and excitation current, that is, E0 equals to F of IF, is called the no-load characteristic. When no load is present, the effective value of the induced electromotive force per phase of the stator winding is E0 equals to 4.44 times F times N1 times kW times 150. As the excitation current increases, E0 will gradually increase due to the influence of magnetic saturation in the magnetic circuit of the machine. The shape of the no-load characteristic curve is similar to the shape of the magnetization curve of the machine. The saturation coefficient K-mu of the magnetic circuit of a synchronous generator refers to the ratio of the air gap line, corresponding to E0 equals UN on the no-load characteristic curve to the extended straight line portion of the curve, and the electromotive force E0 on curve 2 to the rated voltage, that is, K-mu equals E0 over UN. Usually, the saturation coefficient K-mu of a synchronous generator is from 1.05 to 1.25. 2. Short-circuit characteristics. Short-circuit characteristics refer to when the generator speed N is the rated speed and the terminal voltage U is zero, with the armature winding in three-phase short circuit. The relationship between the short circuit current IK and the excitation current IF, that is, IK equals F of IF, is called the short circuit characteristic. When short-circuited, the no-load electromotive force E0 and the phase difference between IK are only affected by the synchronous reactance XT and the resistance of the winding itself. When IQ equals 0 and the winding resistance is neglected, IK lags E0 by 90 electrical degrees. Its armature reaction is demagnetizing armature reaction. The figure shows the equivalent circuit and phasor diagram of a salient pole synchronous generator under steady-state short-circuit conditions. For a salient pole machine, the quadrature axis armature magnetomotive force FAQ is 0 during a short circuit. Therefore, the analysis method is the same as for a non-salient pole machine. Only XT needs to be replaced by XD and I by ID. The demagnetizing effect of the armature reaction reduces the magnetic flux in the machine. The magnetic circuit is unsaturated. Therefore, E0 is proportional to IF. And since IK equals to E0 over XT and the magnetic circuit is unsaturated and constant, IK is proportional to IF. The short circuit characteristic is a straight line through the origin, as shown in the figure. 2. Short circuit ratio Kc. The short circuit ratio refers to when the generator's no-load voltage reaches the rated voltage. The steady-state short-circuit current of the stator winding in 3 phases, and the ratio of IK0 to the rated current IN, as shown in the figure. Kc equals to IK0 over IN equals to IF0 over IF times K. The value of the short circuit ratio Kc affects the performance and cost of the generator. When Kc is small, the short circuit current is small. The cost of the machine is low, but the stability of the grid connection is poor. When Kc is large, the situation is the opposite. The short circuit ratio of a steam turbine generator is usually around 0.6. The short circuit ratio of a hydraulic turbine generator is usually from 0.8 to 1.2. Question 1. What are the basic characteristics of a synchronous generator under symmetrical load? Answer. When a synchronous generator operates stably under symmetrical load, maintaining constant speed, frequency, and power factor, the generator's terminal voltage U, load current I, and excitation current IF are the three main operating parameters. They can all be measured during operation. They are interrelated. When one of these quantities is kept constant, the functional relationship between the other two quantities is called the operating characteristic. The operating characteristics of a synchronous generator include no-load characteristics, short-circuit characteristics, external characteristics, and regulation characteristics. Question 2. Why is the short-circuit characteristic curve of a synchronous generator a straight line through the origin? Answer. When a synchronous generator is short-circuited, the no-load electromotive force E0 and the short-circuit current IK are only affected by the synchronous reactance XT and the resistance of the winding itself. When the winding resistance is neglected, IK lags E0 by 90 electrical degrees. The quadrature axis component IQ is 0. Its armature reaction is demagnetizing armature reaction. The figure shows the equivalent circuit and phasor diagram of a salient pole synchronous generator under steady-state short-circuit conditions. For a salient pole machine, the quadrature axis armature magnetomotive force FAQ is 0 during a short circuit. Therefore, the analysis method is the same as for a non-salient pole machine. Only XT needs to be replaced by XD and I by ID. The demagnetizing effect of the armature reaction reduces the magnetic flux in the machine. The magnetic circuit is unsaturated. Therefore, E0 is proportional to IF, and since IK equals to E0 over XD, and the magnetic circuit is unsaturated and constant, IK is proportional to IF. The short circuit characteristic is a straight line through the origin. In this lesson, we learned the basic concepts of the no-load characteristics and short-circuit characteristics. I hope everyone practices and consolidates this knowledge after class. That's all for this lesson. Thank you, everyone.